sequencer engine start.
Sequencer engine start, armed.
And LC prop lead, I can verify loaded timeline is flight OCCS timeline. And I can also confirm step 251 has been completed. And step 252, mate monitor checks complete and set. And step 253, OCCS is in manual mode and all screens are active. Step 254, switch configuration verified, all PHS switches enabled. And step 255, I can report Descan hoses are installed and post-01 F1 algorithms are not active.
Copy that. Prop lead, check steps 250 through 255. And Core 1, LCN countdown 1. Report values of N for O1 and F1 tanks.
Standby 1.
LC NASA PM.
Go ahead, PM.
Step 28, secondary Bermuda playback stopped.
Copy PM, TLM. Step 29, configure decom for closed loop telemetry.
LC, TLM, and work. TLM on countdown 1, decom config closed loop telemetry.
Copy that, TLM. Check step 29. Ops 2, step 36, apply external power to lithium-ion battery monitor and verify all charge voltages and charge currents are nominal.
LC Ops 2, I copy, and I will work 36 through 42. LC Ops 2, lithium-ion battery monitor power is on. Charge voltages and charge currents are nominal. Battery logging started. Battery monitor communications are nominal, standing by. And 30 seconds have elapsed. Battery logging stopped. And lithium-ion battery monitor power has been removed. 42 in work.
LC, Core 1 on countdown 1.
Go ahead, Core 1.
Yeah, step 256 for you. The target in levels for today for O1 are 16 of 17, for F1, 11 of 17.
Copy, Core 1, 16 and 11. Check step 256. Core 1, direct Yoshinoya to initiate FMS to input N levels into OCCS and report when complete.
In work.
And Ops 2, LC on countdown 1.
Go LC.
Yeah, can you give us a status on step 42?
Yep. Data is being processed and currently being distributed to yourself and elect 1.
Do that, Ops 2. And elect 1, I'll wait for your go on step 43.
LC elect 1 copies.
And NASA PM, verify range ready to support recording of hardline data.
Roger that, LC is ready to support recording of hardline data.
And NASA PM reports status of range video and data lines.
LCC and RCC video and data lines operational.
Copy that. Check steps 44 and 45. And site control, LC on countdown 1. Step 46, start TEL hydraulic system pumps.
And in work. And pump started.
And site control, activate gas power.
And in work. And gas power on.
And Mars E on countdown 1. Step 48, confirm gas power on. Mars TEL, LC on countdown 1.
Mars TEL, standby.
Copy, standing by.
And LC Mars TEL, gas power verified on.
Copy that, Mars TEL. And site control, charge TEL rapid retract system.
And in work.
And Core 1, LC on countdown 1.
Go ahead.
Can I get a status on step 2?
Yeah, still waiting on the return. Standby 1.
And elect 1. LC on countdown 1.
Elect 1 on countdown 1. Go ahead, LC.
Yeah, just checking for status on step 43.
The plots have been verified. The Excel sheet with the cell voltages verification is in work. Standby 1.
And prop lead LC on countdown 1.
Go for prop lead on countdown 1.
I'd like to kick you off on step 259, perform PHS EPV electrical test.
Copy that. I can confirm EPV checks are complete.
Copy that, prop lead.
LC elect 1, countdown 1.
Go ahead, elect 1.
Battery cell voltages are nominal.
Copy elect 1, check step 43.
LC Core 1, countdown 1.
Go ahead, core 1.
In levels have been input into OCCS.
Copy core 1, check step 257. Prop 1, verify N levels in OCCS.
LC Prop 1, I can verify O1 N level of 16 and F1 N level of 11 verified in OCCS.
Copy that, check step 258. And prop 1, configure PHS to initial state.
In work. LC Prop 1, power up initial state command sent. PHS in initial state verified. And FMS sawtooth active. LOL's initial state command in work. Command sent.
And this is Cygnus, go ahead.
And LC Prop 1, LO2 ground system reconfigured.
Copy that. Check step 263. Prop 1, pressurized LO2 launch vehicle interface.
In work. And opening valve 4070 on my mark. 2, 1, mark. Valve 4070 indicates open.
And site control. Step 51, read back stage 1 ECS operating parameters.
And ECU temperature set point is 75 degrees, and flow rate is 2100 CFM. ECU2 temperature set point is 75 degrees, and ECU2 flow rate is 2100 CFM. And ECS interstage bay flow rate is about 900 CFM, and ECS inner tank bay flow rate is about 935 CFM, and ECS aft bay flow rate is 1730 CFM.
Copy all site control. Stage 1, verify stage 1 ECS parameters are nominal.
System, countdown 1.
Go ahead, system.
Yeah, I can confirm those are nominal.
Copy, check step 52. Site control, read back payload ECS operating parameters.
And payload ECU temperature set point is 60 degrees Fahrenheit. Humidity set point is 10%. And flow rate set point is 1815 CFM.
Copy that, site control and system. Verify payload ECS parameters are nominal.
Yeah, LC system parameters are nominal.
And Core 1, verify MSGE is configured to support loading operations.
LC, this is Core 1, that's affirm.
Check step 55. Core 1, verify FMS GE is configured to support loading operations.
Also affirm.
Copy, check step 56. OPM, provide status of LEV doors.
And LC Prop 1 on countdown.
Go ahead, Prop 1.
LO2 LV interface pressurized.
Copy, Prop 1.
OPM is now on countdown 1.
And OPM, step 57, provide status of LEV doors.
LEV doors are secure and ready for LEV pressurization fan.
And LC Prop 1, Helium initial state command sent, GN2 initial state command sent.
Copy that, Prop 1. Check step 265. Prop 2, send OCCS, HSS, and RP1 initial state commands.
LC Prop 2, that's in work.
And site control, step 58, confirm LEV pressurization fan.
And LEV pressurization fan is on, but the primary shutout valves are showing open. Do you want me to close them?
That looks like the desired state. GCE, can you confirm?
That's affirmative. They should be closed.
Your go to close site control.
And copy, they are not closing.
They're slow close. Give it a minute.
Copy.
And GCE step 59, verify HSS GN2 charging configured per 843.
And this is GCE. I can confirm that charging is configured per 843.
Check step 59.
LC Prop 2, Step 266, HSS initial state command sent, and RP1 initial state command sent.
Copy Prop 2. Prop 1, verify all OCCS server sequence controls.
In work. OCCS server auto-sequence controls resumed. All OCCS control loops running.
And Prop 1, arm OCCS for O1 F1 tank desiccant hoses installed.
In work. AC/DC armed.
AC/DC confirmed.
And LC Prop 1, OCCS configured for O1 F1 tank desiccant hoses installed. And OCCS is in auto mode.
Copy that. Check steps through 272. And launch team, we are waiting on some charging and some valves to close, but while we wait for that to complete, we are ready for our first weather briefing. LWO, LC on countdown 1.
LC,
Step 61.
LC, this is Elwell on countdown 1.
Go ahead, Elwell. You are go for step 61.
Copy that. This is Elwell on countdown 1 with this evening's L-4 hour and 20-minute weather briefing. Looking at good conditions across the Wallops area this evening. As we look at the surface analysis, we've got a cold front off to our west that will slowly be approaching the area later this evening. High pressure off the coast, and that's going to combine to give us some southerly winds this evening and good conditions overall. We continue to see those unseasonably warm conditions today and into the overnight hours tonight, with temperatures holding steady in the 60s. Currently out there, temperature is at 66 degrees, and we do have a little bit of low-level cloudiness at around 3,600 feet. Then we have more cloudiness at about the 30,000-foot level with some upper-level cirrus in the area, but none of that is problematic at the moment. We are green as far as any kind of weather criteria go as far as our launch constraint here at Wallops as of this current time. And things looking good overall as we go throughout the next several hours into our countdown. I want to take a look here at our satellite imagery. You can see most of the clouds that we have in the area this evening are of that upper level variety at about 30,000 feet. You can see more of that will be on the way as we go throughout the next several hours. But as I mentioned before, I'm not going to see any problems with that. Off the coast, we do have a little bit of low-level cloudiness showing up, and that'll be what we watch as we go throughout the countdown and approach the launch window later this evening. Looking at our forecast models and what we can expect, precipitation should stay to our west this evening as we watch that slow-moving front really not making much headway towards the Wallops area, just slowly drifting off to the east. And looking at our cloud situation, upper-level winds are in the top, or excuse me, upper-level clouds are in the top right-hand corner of this graphic, and our lower-level clouds are in the upper left-hand corner of this graphic. So as you can see, Model picking up on a little bit of low-level cloudiness off the coast, but fortunately it does look like as we move through the countdown and into the launch window that we will not see an abundance of those low-level clouds in our area, and most of that activity will stay off the coast. Looking at our upper-level winds, you can see the winds generally have a southerly direction from the surface up towards the upper levels of the atmosphere, up around 30 to 50,000 feet. That's where we see our max winds currently residing around 45 to 50 knots, and we will see a little bit higher wind as we get into the launch window, an increase maybe of about 10 knots from where we are right now. This is another way to kind of look at those wind speeds. The red colored line is where we are currently seeing our wind speeds, and the brown colored line is where we expect them to be as we approach the launch window. So as you can see, a gradual increase in those winds as we go through the next several hours, but still not too strong for this time of year, seeing those winds maxing out under 60 knots as we go throughout the countdown. So for our forecasted countdown weather, you can see just a standard deck of clouds around 4,000 feet, a broken deck at 30,000 feet, and a very slight chance that we'll see some lower level clouds develop around the 1,000-foot level, and maybe some reduced visibility as well, but not looking at a very high chance of this occurring at all, as we are seeing those winds out of the south this evening keep the development of any kind of fog or real low cloudiness in our area from developing, with those winds at around 8 to 13 knots sustained and gusting a little higher than that at times. Temperatures expected to remain in the mid-60s as we go through the countdown, and RH values right around 85 to 90%. Sea states off the coast running about 4 to 5 feet. Our Wallops buoy, as of last check, running at around 4 feet at about 10 miles off the Wallops coast. So our launch forecast for this evening, again, looking at a scattered deck around 4,000 feet, broken deck at 30,000 feet, and just that very slight chance of seeing some lower level clouds and maybe some reduced visibility along with those low level clouds developing as we go through the end of the countdown and into the launch window. Winds continuing to be out of the south as we get into the launch window at 8 to 13 knots. Temperatures in the mid to upper 60s, 65 to 67 degrees, and our relative humidity expected at 85 to 90%. Looking at Bermuda weather, they are seeing some showers and some gusty winds out there. Looking at our winds in the launch window to gust at around 26 knots, kind of similar to what they're seeing out there currently with those easterly winds, fairly gusty at times in Bermuda. Temperature 74 degrees and a relative humidity at 62%. So to summarize our launch constraints here for weather, really not tracking any real poor conditions as we go into the launch window. Currently we are green, and the only thing we'll be watching for will be the visibility and cloud ceilings with our sky screen limit at 6,300 feet. We will be watching to make sure we don't see any ceilings over the launch trajectory and off the coast. Looking at very slight, it's only about a 10% chance, so that is down from our 20% probability of violation that we had forecasted at L-minus 24 hours. So things continue to improve, and currently only looking at a 10% chance of violating any kind of weather constraints for our launch. That concludes our L-minus 20-minute launch weather forecast briefing. Any questions?
Hello, this is Stage 1 Mechanical. Can you comment on the ground winds in the T+2 hour range, just in case we have to get into a detanking situation?
Yes, sir. Currently looking at those winds to remain fairly steady. At T0, we are looking at the winds out of the south at 8 to 13 knots, and we're going to expect similar winds at T+2 hours as well. So 8 to 13 knots out of the south with gusts potentially as high as maybe 15 knots.
Copy. Thank you.
And LC Site Control on countdown 1.
Go ahead, Site Control.
Yeah, Tel Rapid Retract charging is complete, and step 50 is not required.
Copy that, site control. Check steps 49. 50 is not required. And do you have a status on step 58?
And admin is looking into seeing if the command was registered. We're not able to get the valves shut at this time.
And site control, Marsdale on countdown 1.
And this is site control on countdown 1.
Yeah, FYI, site control, step 49 remains open for the remaining account. Per the note, we can reperform it if we need to, which we typically do.
Yeah, and copy that.
At GCELC on countdown 1.
This is GC on countdown 1.
Yeah, step 60, verify catch tank is drained.
I can verify catch tank is drained. And LC, GC, did you want me to brief the red team entry?
Yes, go ahead, GC.
Yeah, so we had an issue where the shutout valves for the room pressurization fans did not close, so we're trying to get that to work remotely, but in the meantime, we're going to send the red team in to manually close those valves in case we can't get them to close remotely. And red team ingress to the pad is in work.
All right, copy that, GC. We'll press on with the non-hazardous portions of our pre-power verifications, and stand by for red team status and egress. And launch team, steps 62, OCCS sequencer initiation time will be 7:10:16. Target T0 launch time 10:50:16. Ops 1, LC on countdown 1. Step 63, verify aura and safe and arm status.
In work.
LC Ops 1, Aura and SNA status verified nominal.
Ops 1, check step 6-3. Ops 1, verify plugs, helium emergency vent, and UMBI SEP loop status.
LC Ops 1, in work. LC Ops 1, plugs, helium emergency vent, and UMBI SEP loop status verified nominal.
Copy that, Ops 1. Step 65, verify battery charge enable status.
LC Ops 1, battery charge enable status verified nominal.
Verify pad J-box and tower J-box pressure is on.
Pad J-box and tower J-box pressure verified on.
Ops 1, perform helium vent enable test.
Copy and work. S1, helium vent enable test nominal.
And Ops 1, disable helium vent enable and report status.
LC Ops 1, helium vent enable disabled and nominal.
Copy, check step 68. And OPM LC, countdown 1, step 70, verify pad configuration is complete and ready to support launch operations.
Pad configuration is complete, ready to support launch operations.
All right, launch team, we're going to hold off on our pad clear and verifications and move on to step 74. Verify dynamic limit checker in phase 1, TLM.
LC, TLM, dynamic limit checker is in phase 1.
Core 2.
DLC in phase 1.
MES2.
LC, MES2, DLC in phase 1 in the cab.
And Chimon.
LC, this is DLC in phase 1.
Copy that, Chimon. Check step 74. And step 273, management on station voice checks, CMD.
Yeah, loud and clear, CMD.
Loud and clear, CMD, LD.
LC, this is LD, I have you loud and clear, how me?
Loud and clear, LD, NG.
LC, this is NG, got you loud and clear, how me?
Loud and clear, NG. Check step 273. And admin, input and confirm OCCS sequencer initiation time.
This is admin. I have sequencer initialization time as year 2022, day 310, hour 7, minute 10, seconds 16.0.
Good copy, admin. Check step 274. And Core 1, LC on countdown 1.
Go ahead, LC.
Yeah, I'll just wait for your confirmation of step 275.
Okay, standby 1.
Go ahead, SL1, this is CMD.
LC stepping off station for a moment. LC back on station.
LC, Core 1 on countdown 1.
Go ahead, Core 1.
Yeah, so for step 275, we're going to have to wait until our vehicle power-ups before we get into that.
Sorry, you got stepped on, Core 1. Can you repeat?
Yeah, for step 275, we're going to have to wait for our vehicle power-ups before we get into that.
Copy that. Okay, launch team, at this time, we've got the red team at the pad shutting valves and checking on some ECS. In the meantime, I'd like to poll to initiate the loading timeline sequencer, step 278, Mars site.
Mars sites go.
GSO.
GSO go.
NASA TD. NASA TD.
V.
Yeah, TD, you're coming in broken up. This is the poll to initiate the loading timeline sequencer.
TD's go.
Safety.
Safety is go.
Prop lead.
Prop lead is go.
Stage 1.
Stage 1 is go.
GCE.
GCE's go.
ACE.
ACE is go.
Go to initiate loading sequencer at L minus 3 hours, 40 minutes. All right, launch team, step 58, we had some pressurization fans that would not respond. We've sent in the red team, and they have closed some valves to do the equivalent of what those primary and secondary shutoff valves would do. So we're going to check step 58. And moving on to 69, verify no additional activities requested of personnel at launchpad, GCE.
GCE, you're asking for, we're ready for personnel to clear the launch pad? That's affirmative.
Copy that. Core 1.
Core 1 concurs.
Mars site.
Mars site's ready for personnel clear pad.
Copy. Check step 69. OPM, LC on countdown 1. Evacuate launch site to initial fallback area.
This is OPM. Launch site evacuation is in work, and personnel are clear of the vehicle.
And GSO, announce evacuation of launch site on public address VoiceNet and report when launch site is clear of personnel.
Say in work.
And I can confirm OCCS sequencer startup. And step 280, place the dynamic limit checker in automatic mode, TLM.
In work.
LC prop lead on countdown 1.
Go ahead, prop lead.
Did we run SEP 277? Yeah, I don't believe we have.
No, not yet.
LC, TLM, DLC in automatic mode.
Prop lead, yeah, we can run 277 now. Prop 2, your go for step 277, turn on heater 5181 and 5182.
LC prop 2, that's in work. LC prop 2, GN2 heaters powered on.
Copy that, prop 2. TLM, LC on countdown 1.
Go ahead, LC.
Yeah, step 280, place the dynamic limit checker in automatic mode.
DLC in automatic mode.
Core 2.
DLC in automatic mode.
And Chimon.
Chimon and DLC in automatic mode.
Check step 280. Go ahead, GSO.
Yes, sir. Check item 7273.
Copy that, GSO. All right, team, this completes all steps through step 74. Okay, launch team, at this time, I'd like to proceed into Antares power-up, starting on step 75, TLM at DCOM setup telemetry archive.
In work, and our archive name is 20221106 underscore 861 underscore 1 underscore NG18 underscore launch underscore P as in Papa underscore 1.
Copy that, TLM. Step 76, pull for launch vehicle external power on, Mars CE.
Mars CE's go.
GSO.
GSO go.
RSO.
RSO go.
NASA TD.
TD's go.
Ops 1.
Ops 1 go.
Ops 2.
Ops 2 go.
Elec 1.
Elec 1 is go.
GCE.
GCE's go.
ACE.
ACE go.
Go for external power on. TLM, start G2 recorder and read back system time.
In work. LC TLM, recording started. System time is 2022 310 07 1440.
Check step 77. And TLM, start MCC TDS distributor logging, split the GTLM log and verify logging to intended directory.
Start up and work.
LC, TLM, logging started and split, verified logging to correct directory.
And Ops 1, verify failsafe panel indicates all safe.
LC Ops 1, all safe illuminated.
And Red Team Lead, be advised external power being applied to vehicle. Verify all personnel 400 foot clear of launch pad until further notice.
Red Team Lead copies, confirm clear.
1, apply external power to systems as listed.
LC Ops 1 in work. Avionics encoder RF switch, external power on. Flight computer, external power on. Standby 20. LC Ops 1, motor cone encoder, external power on. Stage 1 encoder, external power on. Standby for ground lock. Ground lock, external power on.
And TLM, verify lock on data streams and start telemetry archive.
Waiting on lock. Verified lock on all data streams. Archiving started.
Ops 1, continue applying external power to systems as listed.
Copy. Main engine encoder alpha, external power on. Stage 1 controller, HG1700, external power on. ACM, external power on. Instrumentation, external power on. Main engine encoder Bravo, external power on. OrbNav, HG9848, external power on.
And Elect 1, verify all mocks are synced to PTP server.
LC Elect 1, all mocks synced to PTP server.
Ops 1, apply external power to remaining systems.
H2 ECU, external power on. Storm, pressure transducer, external power on. SMI power A, B will come up also, external power on.
And step 86, Ops 1, verify external power indications are nominal.
LC Ops 1, all external power nominal.
LC Elect 1, external power parameters nominal.
And Ops 2, issue catalog roll-up command.
In work. And LC Ops 2, catalog roll-up command issued. Standby for verification.
LC copies. Check step 88.
LC prop lead on countdown 1.
Go ahead, lead.
I have step 284 for you. Lost showdown started. And just a reminder that we have not completed 282 yet.
And LC Ops 2.
Go ahead, Ops 2.
Vehicle roll-up digest verified with engineering. Would you like that mission SVDD?
If you could record that and follow up with me after the operations today.
Welcome.
And TLM, step 283 at decom stop and restart telemetry archiving.
Copy in work.
NASA PM, step 90, verify range TM receiving hardline link 87, 69, and 41 data.
LC NASA PM, that's A-firm, range receiving hardline link 87, 69, and 41.
LC, TLM.
Go ahead, TLM.
Archiving stopped and restarted.
Check step 283. And TLM, your go for step 91.
Copy, and we are receiving all streams closed loop telemetry.
Copy, check step 91. SLM, verify receipt of Cygnus hardline telemetry.
LC, SLM, we are receiving Cygnus hardline telemetry.
Site control, report status of tail, rod, and cap pressures.
And rod and cap pressures require adjustment.
Copy that, site control, your go for step 94.
Copy. Do you want me to use anomaly one for that?
Yes, anomaly 1. And who do you need with you?
Marstel and safety.
Copy that. Report when you've completed Appendix Alpha Echo. GNC 1, provide optimal launch time, step 95.
LCGNC 1, optimal launch time for today's operation is year 2022, month 11, day 6, hour 10, minute 52, second 45.129.
Copy that, GNC 1. Ops 1, upload optimal launch time to flight computer.
LC Ops 1 in work.
LC prop lead on countdown 1.
Go ahead, lead.
I have step 285 for you. FMS is ready.
Copy that, lead. And Core 1, LC on countdown 1.
Go ahead.
Yeah, can I get a status on step 275?
Step 275 is complete, and TLM is step 276 in work.
And LC, TLM, 276 complete, data stream enabled.
Copy that. Check step 275 and 276.
LC Ops 1, optimal launch time uploaded.
Go ahead, DPM.
Copy that, Ops 1. Check step 96.
LC GNC1, optimal launch time verified in
Range
telemetry.
instrumentation setup is complete. Tasks 4.1 through 6.7 of the end-to-end test are complete.
GNC1 provides Cygnus and Antares final mass property inputs.
LC GNC1, the Antares stage 2 ignition mass is 58970.38 pounds. Reference memo ME070-3251. The Cygnus stage 2 ignition mass is 17853.47 pounds. Reference memo CRS memo MSE 2022-086 Rev B. Total stage 2 ignition mass is 76823.85 pounds.
Copy that. GNC1 SLM verify Cygnus final mass and reference memo.
LC SLM, Cygnus final mass and reference memo verified.
MEC1 verify Antares final mass and reference memo.
MEC1, Antares final mass and reference memo verified.
Ops1 enter stage 2 ignition mass into flight computer.
Copy and work. LC Ops 1, stage 2 ignition mass entered.
LC GNC1, stage 2 ignition mass verified in telemetry.
Check steps through 102. MES2, report fuel density value for operation.
LC MES2, fuel density value 0.8.
And this is LC back on countdown 1. Ops 1, enter fuel density into flight computer.
LC and work. LC Ops 1, fuel density value entered.
LC MES1 on countdown 1.
Go ahead, MES1.
Fuel density entered is 0.812. Expected since there's just a 3 decimal buffer.
Copy that, MES1. Check step 105. Elect 1, report readiness for stage 2 ECU initialization.
LC Elect 1 is go.
Ops 1, set and verify ECU command values.
LC and work. LC Ops 1, ECU command value set.
Copy that. Ops 1, initialize system.
Copy and work. LC Ops 1, pitch 0.0, yaw 0.0 been entered. Initialize has been selected, and we started ECU comm.
Copy that, Ops 1.
And message counter incrementing.
LCTLM, message counter incrementing at the decom.
And TLM, report pitch and yaw LVDT positions.
For stage 2 TVC01, I have 0.136 degrees. Stage 2 TVC02, I have 0.001 degrees.
LC elect 1, pitch and yaw LVDT positions are acceptable.
Copy that, elect 1. Stage 2 ECU initialization complete. Check all steps through 113. And Core 2, Step 281. Verify MS session is running and CSOE is ready for mode 4.1, 4.3 checks.
LC Core 2, MS session running, CSOE ready to support 4.1, 4.3 checks.
Prop 2, perform Hartron controller comm checks with OCCS and provide status when complete.
LC Prop 2, that's in work.
All right, launch team, I'd like to proceed into our open loop RF and transmitter checks. Step 114, poll for transmitter checks and open loop RF. Safety?
Safety is go.
GSO?
GSO go.
NASA TD?
TD's go.
SLM?
SLM go.
Ops 1?
Op 1 go.
Elect 1?
Elect 1 is go.
Go for open loop RF and transmitter checks. Ops 1, verify RF switches at lower.
LC Ops 1, C-band RF switch set to lower. TLM RF switch set to lower.
NASA PM, verify range is not interrogating vehicle transponder.
Affirmative, range confirms, no interrogation of vehicle.
Ops 1, apply external power to transponder RF switch.
LC Ops 1, transponder RF switch.
Break on countdown 1, elect 1. Just wanted to call out, looking at page 11, the RF switch. I have C-band is upper and S-band is lower. Can I get a confirmation on countdown 1?
That's because we don't.
LC Prop 2, Hartron controller to OCCS comm checks complete and sat.
Copy that, Prop 2. And Core 1, your go for Step 286.
LC Ops 1 on countdown 1.
Go ahead, Ops 1.
Are you ready for transponder RF switch external power on?
Affirm, Step 117, go.
Transponder RF switch external power on my mark. 3, 2, 1, mark. And the time is 07:34:16.
Check Step 117. Core 1, LC on countdown 1.
Go ahead.
Yeah, your go for 286.
LC Ops 1.
In work.
Transponder RF switch external power nominal.
LC elect 1, RF switches set to lower.
Waiting 2 minutes for transponder power up. And NASA PM, confirm active radar sites and begin C-band transponder interrogation per the Antares mission radar transponder interrogation checklist.
LC NASA PM, that's in work.
And LC site control on countdown 1.
Go ahead, site control.
And rod and cap pressure adjustment procedure is complete. Step 94.
Copy that, site control.
LC NASA PM.
Go ahead, PM.
Yes, sir. SEP 120, we are in work. Note that per our CST, we do each radar separately, so it takes a little bit of time. We are actively doing radar 5. When they're complete, we'll do radar 18. When they're complete, we'll do radar 3.
Copy that, PM. And Ops 1, apply external power to vehicle transmitters.
LC Ops 1, avionics telemetry transmitter, external power on. Motor cone transmitter, external power on. Stage 1, telemetry transmitter, external power on. LC Ops 1, vehicle transmitters, external power nominal.
LC Elect 1, external power status nominal.
Copy that. Check steps 123, 124, 125. NASA PM, confirm range is receiving open loop telemetry from all vehicle links.
Stand by. LC NASA PM.
Go ahead, PM.
Step 126, range receiving open loops, link 41, 69, and 87.
Copy that, PM. And PM, your go for step 127, direct range TM to switch to recording open loop telemetry.
In work.
Yeah. I've got step, copy that. I've got step 286 for you. The first session has stopped.
Copy that, Core 1. Check step 286. TLM, disable Usinoia data stream.
LC, TLM, Usinoia data stream disabled.
And GSO, step 288, begin implementation of pad clear zone and report when complete.
LC GSO 1190 set. Red team remains at Zulu 65.
Copy that, GSO. Check step 288. GCE LC on countdown 1, step 289, provide direction of HPGN2 circuit configuration.
This is GCE. We're going with the primary circuit.
Copy that, GCE. Step 290, prop 2, initiate HPGN2 on primary.
LC, that's in work.
LC NASA PM.
Go ahead, PM.
You can check 127 range recording open loop telemetry.
Copy that, PM. Your go to begin S-band assessment.
In work, thank you.
LC, prop 2, HPGN2 charging on primary.
Copy that, prop 2. Check step 290. 291 is not required.
LCMES2 PSPI indicates GN2 charging.
Copy that. Check step 292. GCE, provide direction on warm helium circuit configuration.
And this is GCE. We're going with the primary circuit on helium as well.
Copy that, GCE. Prop 1, you go to initiate warm helium charging on primary.
LC prop 1 in work. LC prop 1, warm helium charging started on primary.
Copy that, prop 1. Check step 294. 295 is not required. Red team lead, LC on countdown 1. Be advised, 293-foot line of sight clear from launch vehicle aft bay is required for remainder of operation. Confirm clear.
Copy and confirm clear.
Prop 1, start charging of engine helium bottles.
In work. Opening VTD on my mark. 2, 1, mark. LC prop 1, engine bottle charging started.
LC admin, VTD state set.
LC MES2 helium bottles charging.
LC prop 1, OCCS in auto mode.
Copy that. Check steps 297, 298, 299, and 300. TLM, step 129, configure decom source to open loop telemetry.
LC TLM, copy and work.
LC NASA PM.
Go ahead, PM.
Yes, sir. I can give you step 120. We're interrogating, and I can give you step 121, holding beacons.
Copy that. Check step 120 and 121.
LC TLM step 129, decom switch to open loop telemetry.
Copy that, TLM. And NASA PM, your go for step 122. Proceed with C-band evaluation and report when complete.
Yes, sir. Inward.
Step 130, verify open loop telemetry received and nominal. TLM.
Open loop telemetry received and nominal in the MCC.
MES2.
LCMES2, open loop telemetry received and nominal in the cab.
SLM.
LC, SLM, open loop telemetry received and nominal in H100.
Check step 130. NASA PM, step 131, status S-band assessment, confirm assessment email to launch vehicle recipients.
That's still in work. We'll email when complete.
LC copies. And launch team, be advised, if you get an error in your GTLM, you are advised to close the program and restart it from the desktop. And launch team. Current status, we're waiting for the completion of the C-band and S-band assessments from the range before we proceed with closing out our open loop RF and transmitter checks. Once we complete that, we'll move on to FTS and power systems testing. We are not currently tracking any red conditions. Okay, launch team, slight change of plans. We're going to press into our FTS and power systems test while we remain open loop. Step 136, pull for FTS external power on. Safety?
Safety's go.
GSO?
GSO go.
FSO?
FSO go.
NASA TD?
T's go.
Ops 1?
Ops 1 go.
Ops 2?
Ops 2's go.
Elect 2?
Elect 2 is go.
Go for FTS external power on. FSO, bring up command transmitter with check channel on.
In work.
LC NASA PM.
Go ahead, PM.
Yes, sir. I can give you step 122. C-band evaluation is complete and emailed.
Copy that, PM.
S-band is shortly behind.
And LC, FSO, Wallops CT site on, check channel radiating.
Copy that, FSO. Check step 137. And Ops 1, apply external power to FTSA and FTSB.
FTSA external power on. FTSB external power on.
FTS external power nominal.
And elect 2, step 140, verify FTS indicates safe and receiving check channel with nominal AGCs.
Doesn't work. FTS safe, receiving check channel, signal strength nominal.
Copy that, elect 2. NASA PM, verify range radar and range telemetry ready to monitor C-band and S-band operation during avionics internal power test. whoever's on countdown 1 watching the Orb 3 video, please close your mic. NASA PM LC on countdown 1.
NASA PM, go.
Yeah, step 141, verify range radar and range telemetry ready to monitor C-band and S-band operation during avionics internal power test.
Step 141, range ready to support.
Step 142, poll for avionics and FTS internal power test, GSO.
GSO, go.
FSO.
FSO, go.
NASA TD.
TD's go.
Ops 1.
Ops 1, go.
Elect 1.
Elect 1 is a go.
Go for avionics and FTS internal power test. Ops 2, start battery logging.
LC Ops 2, battery logging on. Stand by for verification of comm. And lithium-ion battery monitor comm is nominal.
Copy that. Check step 144. Ops 1, transfer avionics and FTS power to internal.
LC Ops 1, all internal power on my mark. 3, 2, 1, mark. The time is 07:58:50.
LC Elect 1, internal power nominal.
LC Ops 1, all external power is off.
Check step 146 and 147. NASA PM, verify with range radar, no change in C-band operation.
Stand by. LC, NASA PM 148, C-band operations confirmed nominal, working S-band right now.
Copy. PM, check step 148, 149, and work.
LC, I can give you 128 and 131. Should have S-band in your email.
Copy that. PM, elect 1. Step 132, confirm receipt of S-band assessment and report status.
LC Elect 1, assessment received, and review and work.
LC NASA PM, I can give you 149, S-band operations confirmed nominal.
Copy that. PM. Ops 1, switch avionics and FTS external power on.
LC Ops 1 and work. LC Ops 1, all external power on. LC Ops 1, all internal power off on my mark. 3, 2, 1, mark. The time is 08:01:30.
LC Elect 1, avionics external power nominal.
Op 2, remove lithium-ion battery monitor power and discontinue logging.
LC Ops 2, lithium-ion Logging is off, and lithium-ion battery.
Copy that, Ops 2. Check step 153.
LC Ops 2, countdown 1.
Go ahead, Ops 2.
Yeah, sorry, just wanted to confirm that you heard my readback on 153 being complete.
That's a firm.
Copy.
LC elect 1.
Go ahead, elect 1.
I have step 132. Status appears nominal.
Copy that. Check step 132. TLM, switch decom source to closed loop telemetry.
LC TLM, copy inward. LC TLM, countdown 1, decom configured for closed loop telemetry.
Copy TLM. Step 134, verify closed loop telemetry received and nominal. TLM.
Closed loop telemetry being received and nominal in the MCC.
MES2.
MES2, closed loop telemetry received and nominal in the cab.
SLM.
LCSLM, closed loop telemetry received and nominal in H100.
And NASA PM, direct range TM to switch to recording orbital decom source.
Roger, in work.
Step 155, poll for FTS arm command test. FSO.
FSO go.
NASA TD.
TD's go.
Ops 1.
Ops 1 go.
Elect 2.
Elect 2's go.
Ops 1, transfer FTSA and FTSB to internal power.
Copy and work. LC Ops 1, FTS A and B internal power on, external power off, and the time is 08:05:06. LC Ops 1, FTS status nominal.
FTS internal power nominal, ready for FTS receiver arm. Check steps through 158. 159, FSO, send FTS receiver arm command for 2 seconds, and continue check channel when function removed.
FSO, arm on my mark. 3, 2, 1, mark. +1, +2, arm off. Check channel continued.
FTS arm indication received. FTS currently indicates safe. FSO, verify FTS arm indication.
FTS arm indication.
FTS safe in arm and FTLU safe. Ops 1, open FTS UMBI loop and verify green indication.
LC Ops UMBI loop open and green.
FTLU and FTS receiver indications are nominal. Check step 164. Ops 1, close FTS UMBI loop and verify red indication.
LC Ops 1, FTS UMBI loop closed in red.
Ops 1, transfer FTSA and FTSB to external power.
Copy and work. LC Ops 1, FTS A and B on external. Internal power is off, and the time is 08:06:50.
FTS external power status, voltage, and current are nominal. FTS safe configuration verified, check channel being received. Let me know when you're ready for the AGCs. Ready, Elect 2. AGC for FTL UA is 4.85. AGC for FTL UB is 4.84. Copy that, Elect 2. Check steps 166, 167, and 168.
LC NASA PM.
Go ahead, PM.
We can give you step 135, range recording orbital decom source.
Copy that, PM. Check step 135. And launch team, that completes all steps through 168. We're going to proceed into SA ARM and ODM enabled test, step 169. Red team lead, be advised, 400-foot launch pad clear required during SA ARM and ODM enabled test. Confirm clear.
Red team lead copies, confirm clear.
Ops 2, initialize ground EPV power supplies.
LC Ops 2, ground EPV power supplies initialized.
Ops 2, initialize ground ordnance power supplies.
And ground ordnance power supplies initialized.
Ops 1, transfer FTSA and FTSB to internal power.
LC Ops 1 and work. LC Ops 1, FTSA and B internal power on, external power off, and the time is 08:09:10.
FTS internal power parameters nominal. Check step 172, 173. Ops 1, activate arm enable.
LC Ops 1, arm enable rotated, arm enable illuminated.
Ops 1, send all arm command.
LC Ops 1, all arm command sent.
LC Elect 1, ground ODM armed. Stage 1 controller ODM armed. Flight computer ODM armed. Stage 2 ignition and aura safe and arm indication. FTS A and B, safe and arm indication.
Copy that, Elect 1, check step 176. Ops 1, safe vehicle SNAs and vehicle and ground ODMs and verify ODM safe.
LC Ops 1 and work. LC Ops 1, vehicle SNAs and vehicle ingress saved.
Copy that,
LC Elect 1, ground ODM safe indication. Stage 1 controller ODM safe indication. Flight computer ODM indication. Stage 2 ignition and aura safe and arm safe. FTS A and B safe and arm safe indication.
Copy all, Elect 1. Ops 2, reset ground ODM power supply.
LC Ops 2, ground ODM power supply reset.
And Ops 1 for SA and FTSB to external power.
Copy. LC Ops 1, FTSA and B external power on and internal power off, and the time is 08:11:20.
FTS external power status, voltage and current nominal. And Ops 1, remove FTS power.
LC Ops 1, FTSA and B external power is off.
And SO, secure CT site and verify RF silence.
In work.
LC, CT site key down, R silence verified.
Roger that, FSO. Check step 183. Ops 1, deactivate arm enable at failsafe panel.
LC Ops 1, arm enable key rotated and arm enable no longer illuminated.
NASA PM CC band transponder interrogation and deactivate radar sites.
We're in work.
And LC prop lead on countdown 1.
Go ahead, prop lead.
I have step 301 for you. Start of heated GN2 supply verified.
Copy that, lead. Prop 1, step 302, adjust EREG 5269.
In work. LC MES2, step 303, helium, warm helium system, steady state observed.
Copy that, MES2.
LC NASA PM.
Go ahead, PM.
No, give your 185, C-band transponder interrogation stop, radar sites deactivated.
Copy that. Check step 185.
LC Prop 1, 5269 adjusted to 1350 PSIG.
LC copies, Prop 1. Okay, launch team, as our liquid oxygen system continues to chill down through phase 3, I'd like to proceed with our EHS functional tests on step 186. Poll to perform stage 1 EHS functional, GSO.
GSO go.
Prop 2.
Prop 2's go.
Prop lead.
Prop leads go.
Ops 1.
Ops 1 go.
Ops 2.
Ops 2 go.
EHS 1.
EHS 1 go.
EHS 2.
EHS 2 is go.
MES 2.
MES 2 is go.
ACE.
ACE is go.
Go for EHS functional. Ops 2, initialize ground EPV power supplies.
LC Ops 2, ground EPV power supplies initialized.
LC elect 1, ground EPV power supplies initialized, voltage is nominal.
Check step 187, 188. Ops 1, step 189, activate arm enable.
LC Ops 1, arm enable rotated, arm enable illuminated.
Ops 1, arm ground ODM.
LC Ops 1, ground EPV ODMs armed.
LC elect 1, ground ODMs 4 through 7 indicate armed.
LC Ops 1, ground EPV ODMs indicate armed, ground ODMs remain safe.
Copy. Check steps 191 and 192. Ops 1, deactivate arm enable.
LC Ops 1, arm enable key rotated, arm enable no longer illuminated.
Ops 2, set ground EPV VREFs.
LC Ops 2, ground EPV VREFs set.
LC elect 1, ground EPV VREF set, voltage is nominal.
Red team lead, be advised, 51-foot Vehicle clear required until completion of hydraulic supply to EHS. Confirm clear.
Copy and confirm clear.
Prop lead, verify accumulators 8006 and 8007 are ready for EHS functional.
LC prop lead, accumulators verified ready.
Prop 2, place OCCS into SAC mode. Pause the HSS auto sequence control.
LC, Prop 2, that's in work. LC, Prop 2, HSS ASC is paused.
Prop 2, open valve 8021.
Opening 8021 on my mark. 3, 2, 1, mark. (8021) indicates open.
And hydraulic supply valve configuration verified.
Check steps 19200. Prop 2, confirm HSS GN2 pressure 2 accumulators.
LC, Prop 2, that's in work.
LC, HS1, I can verify pressures are nominal.
LC, Prop 2, 5464 is closed, 5463 is open.
And LC prop lead, HSS GN2 valve configuration verified.
Check steps 201, 202, and 203. Ops 1, transfer SMI A and B power to internal.
LC Ops 1 in work. LC Ops 1, SMI power to internal. LC Ops 1, TVC and EHA buses enabled.
LC Elect 1, SMI power nominal.
Ops 1, initialize stepper motors to their null positions.
Initialize all, initialize on my mark. 3, 2, 1, mark. The time is 08:20:13.
LC, HS1, stepper motors are at the null position.
And Ops 1, set radial and conical ramp rates for EHS functional.
Copy and work. LC Ops 1, ramp rate set. LC Ops 1, stop limit set at 4.2. LC Ops 1, engine position mode set to synchronize.
Copy all Ops 1 through 211. Ops 1, start TVC actuator comm.
LC Ops 1, actuator comm started.
Ops 1, start TVC sweep test. Ops 1 to announce start of each cycle and EHS 1 to confirm after each cycle.
Copy. LC Ops 1, 4-degree radius ramp rate, radius conical slew test on my mark. 3, 2, 1, mark.
sweep complete, ready for next cycle.
LC Ops 1, 4-degree radius conical slew test starting on my mark. 3, 2, 1, mark.
LC EHS-1, sweep complete, ready for next cycle.
LC Ops 1, 4-degree radius conical slew test starting on my mark. 3, 2, 1, mark.
LC EHS-1, TVC sweep complete and set.
Copy that. EHS-1, check steps 213 and 214. Ops 1, stop TVC actuator comm.
LC Ops 1, TVC actuator comm stopped.
Ops 1, start EHA actuator comm.
LC Ops 1, EHA actuator comm started.
Ops 1, start EHA sweep test.
Starting EHA 50 Hz sweep test on my mark. 3, 2, 1, mark. Test in progress.
EHA sweep complete and set.
Copy that. EHS-1, Ops 1, stop actuator comm.
LC Ops 1, EHA actuator comm stopped. TC Ops 1, TVC and EHA buses disabled.
Copy Ops 1, and Ops 1, your go for 221. Close EHS hydraulic supply valve.
Closing 8020 on my mark. 3, 2, 1, mark. 8020 closed.
And prop lead, LC on countdown 1.
Go for prop lead.
Verify valve 8020 closed.
I can verify that valve 8020 is closed.
LC EHS-1, I can verify hydraulic pressure has been removed from the vehicle.
Copy EHS-1. Ops 1, transfer SMI A and B power to external.
LC Ops 1 in work. LC Ops 1, SMI power to external.
Check steps 223 through 224. Prop 2, reconfigure HSS GN2 valves to pre-launch configuration.
LC Prop 2, that's in work. LC Prop 2, HSS GN2 valves reconfigured. HSS GN2 is venting.
Copy, Prop 2.
And LC prop lead, I can verify that HSS GN2 is vented.
Copy, Prop lead.
And LC Prop 2 closing 8021 on my mark. 3, 2, 1, mark. 8021 is closed. And HSS auto sequence control is resumed, and OCCS is back in auto mode.
Copy that, Prop 2. This completes our EHS functional tests. And launch team, before we proceed into our discrete tests, be advised we've sent in the red team. We're having some issues with the core ECS dew point. The red team is going to go in and connect some additional compressors. We'll stand by for the red team to go in and accomplish that task before we proceed with our discrete tests on step 229.
Got a voice, Dallas, countdown 1.
And got a voice copy, U5 by.
Got a voice, Dulles, countdown 1.
Dulles, this is Got a Voice. How do you copy? Dulles, this is Got a Voice on countdown 1. How do you copy?
Five by 5, Dulles.
Sterling Got a Voice on countdown 1. Cygnus countdown 1. Copy. OSC Got a Voice on countdown 1. How do you copy?
And Core 1 LC on countdown 1.
Go ahead.
Yeah, you're go for step 306.
Copy and work.
LC prop lead on countdown 1.
Go ahead.
Step 304, phase 3 flow rates are nominal, and we do not need adjustment.
Copy that, prop lead. And site control. Step 308, tail arm preload.
And in work. And LC Site Control on countdown 1.
Go ahead, Site Control.
And TEL is adjusted.
And Site Control, command TEL arms to open.
And in work. And LC Site Control on countdown 1. TEL arms opened. Step 309 complete.
Copy that, Site Control. Your go to remove gas power.
And gas power off.
Site Control, move TEL to vertical position.
And in work.
And step 312, verify readiness to perform engine pressure switch check. MES2.
MES2 is go.
Ops 1.
Ops 1, go.
Elect 1.
Elect 1 is go.
Ready for engine pressure switch check. Ops 1, activate engine pressure switch check.
Pressure switch check starting on my mark. 3, 2, 1, mark. Pressure switch check activated.
And LC Site Control, TEL is at vertical.
Copy, Site Control. Check step 311.
LC elect 1, engine pressure switcher check nominal.
LC Core 1 on countdown.
Go ahead, Core 1.
I've got step 306 for you. The second MS session has started. Approximate start time of 084014 UTC.
Copy that, Core 1. And TLM LC on countdown 1.
Go ahead, Elsie.
You are go for step 315.
Step 315, complete 316 in work. LC, TLM, GTLM logging started for Yuzhnoy data stream.
And TLM, I got a call for core 2 on that step. Is that a typo?
That was a conversation we had. That duty shifted to me. My apologies.
Roger that. Check step 316. Core 1, step 317. Request Yuzhnoy to verify orbital decom data is being received and recorded, and MTU hardline data is being received and recorded. Report when complete.
Core 1 copies and work.
Core 1 LC on countdown 1.
Go ahead.
Yeah, did you hear my call on step 317?
Affirm, yeah, in work.
Thanks. Copy.
LC, Core 1, countdown 1.
Go ahead, Core 1.
Yeah, I got step 317 now. MS data and MTU hardline data are both being received and recorded.
Copy that, Core 1.
And LC, TLM, we are receiving Yuzhnoy stage 1 data stream.
Copy TLM. Step 319, confirm nominal Yuzhnoy vehicle telemetry. TLM.
Nominal display of Yuzhnoy telemetry is confirmed in the MCC.
Elec 1.
LC Elec 1, nominal display of Yuzhnoy telemetry is confirmed in room 100. 111.
And Core 2.
LC Core 2, nominal display of Yuzhnoy telemetry is confirmed in E100.
And check step 319. and launch team. Status, red team has made some adjustments in the ECS room. They're now moving over to the 414 panel to make an adjustment to regulator on the helium side and to burp a regulator. We're coming up on our 30-minute hold. CDT stop time is 90016 Zulu. We have completed all steps through 228. Our remaining section of vehicle tests are the discrete tests starting at step 229, which we will kick off as soon as the red team egresses from the pad. We're standing by for the results of the red team on the ECS system regarding the dew points in step 307. We have otherwise completed all steps through 319 and our Lowell's chill down. LC stepping off console. LC back on station.
Testing 1, 2, 3.
And LC GCE on countdown 1.
Go ahead, GCE.
Yeah, so it looks like we got that core resolved by switching the fuses, and we had the red team stop by the 414 panel and vent the backup regs for both helium and nitrogen. We're happy with where the regs are now, and the red team is leaving the pad.
Copy that, GCE. Thanks for the summary. Good job, team. Site control LC on countdown 1.
And go for site control.
Step 307, verify ECS air dew points.
And ECU 1 dew point is negative 43.5, and ECU 2 dew point is negative 27.9.
Copy that, site control. Red team lead, LC on countdown 1.
It's red team lead, go.
Yeah, red team, with your efforts at the pad, complete your go for step 321. Evacuate red team to V50. Notify upon arrival.
Copy that. Red team falling back to Victor 50.
And MES2, I got your required, not required steps since 322. Thank you.
Copy.
Okay, launch team, this time I'd like to proceed into our discrete tests. Our CDT will be holding in just under 2 minutes. Step 229, report readiness for calibration of sensors, MES2.
MES2 is go.
EHS1.
HS2 as go for EHS1.
Copy that, EHS2. Elect 1.
Elect 1 is go.
Ops 1, set engine pressure sensors to cal mode.
LC Ops 1 and work. LC Ops 1, engine pressure sensors recalibrated and returned to flight mode.
LC Elect 1, engine pressures calibration executed and verified in flight mode.
And Ops 1, set charge amps to flight mode.
LC Ops 1, charge amps set to flight mode.
LC Elect 1, engine sensor charge amps verified in flight mode. LC elect 1, discrete signals verified nominal.
Copy all. Elect 1. Step 235. Press the local launch enable button at failsafe panel and verify indicator is illuminated. Ops 1.
LC Ops 1, launch enable press and illuminated.
GSO.
LC GSO launch enable verified.
Step 236. Verify local launch enable indicator at failsafe panel is illuminated. RSO.
Illuminated.
FSO.
Launch enable verified.
NASA PM.
Launch enable verified.
NASA TD.
Launch enable verified.
Check step 236. Ops 1, verify global launch enable indicator at failsafe panel is illuminated.
LC Ops 1, global launch enable verified.
LC elect 1, discretes verified nominal.
I can confirm we are holding at T-minus 1 hour, 20 minutes. Step 239, cycle local launch enable button. RSO.
In work. LC, RSO on countdown 1, launch enable cycled, indications nominal.
FSO.
FSO hold on my mark. 3, 2, 1, mark. 3, 2, 1, release. FSO launch enable cycled, indications nominal.
NASA PM.
NASA PM. Hold on my mark. Mark. Release. Launch enable cycled, indications nominal.
NASA TD.
In work. Program will hold on my mark. 3, 2, 1, hold. And release. LCTD launch enable cycled, indications nominal.
Ops 1.
Ops 1 in work. LC Ops 1, launch enable cycled, indications nominal.
GSO.
LC GSO launch enable cycled, indications nominal.
GSO, remove local launch enable.
Launch enable removed, verified off.
LC Ops 1, launch enable removed, verified off. Global launch enable, verified off.
LC elect 1, discretes verified nominal.
Ops 1, I apologize. Did you give me 242 in addition to 241?
Yes, sir.
Copy that. Site control, LC on countdown 1, step 323, re-verify ECS air dew points.
LC cycle, ECU1 number 1 dew point is negative 46F, and ECU2 dew point is negative 29F.
And GCE, verify heated GN2 pressures and temperature.
And heated GN2 pressures and temperatures are nominal.
Elwo, LC on countdown 1.
LC, this is Elwell on countdown 1.
Yeah, we are ready for your updated weather briefing.
Copy that. This is Elwell on countdown 1 with our updated weather briefing at L-1 hour and 50 minutes. Conditions still looking very favorable for launch tonight. We currently just have a few clouds at 4,000 feet and an overcast deck of cirrus cloudiness at 30,000 feet in the atmosphere. Neither of those cloud levels are causing us any issues with our landing and launch commit criteria. Our winds are currently out of the south-southwest at 5 to 10 knots, and our temperature is holding steady at around 66 degrees. Relative humidity is at 86%. I want to take a look at our satellite. You can see all of the upper-level cloudiness streaming in from the west, and that's the majority of our cloud coverage now. Just a little bit of low-level cloudiness off the coast. You can see some of the low-level clouds and associated sprinkles well off the eastern shore coastline this morning. But again, none of those showers or clouds are causing us any issues, and we don't expect any as we work our way through the countdown and into the launch window. So taking a look at our countdown forecast, holding the same sky coverage that we're currently seeing with just a few clouds at 4,000 feet and overcast deck at 30,000 feet. We will see the upper-level cirrus cloudiness decrease a bit as we work our way to the end of the countdown and into the launch window. Winds should hold out of the south-southwest at around 8 to 13 knots, with temperatures in the mid-60s, relative humidity 85 to 90%. So our launch window forecast looking very similar to the remainder of the countdown with the same sky coverage expected. Our winds out of the south-southwest at 8 to 13 knots, and our temperature at 65 to 67 degrees. So currently not tracking any issues for launch as far as weather constraints go, and we are not expecting any to occur as we go into our launch window. So that concludes our weather briefing. Any questions?
Thanks for your support today, Elwo. GSO, LC on countdown 1.
GSO.
Step 326, confirm pad clear zone implemented.
Standing by for confirmation for red team on their arrival.
10-4. And launch team CDT will resume at 9:30:16.
And LC red team lead countdown 1.
Go ahead, red team lead.
The red team has arrived at V50.
Copy that.
LC GSO.
Go ahead, GSO.
Yes, check item 326.
Copy. Coming up on our poll to begin propellant loading operations in under 3 minutes. All right, we're ready to begin our poll to begin propellant loading operations. Step 328, Mars site.
Mars site is go.
GSO.
GSO go.
RSO.
RSO go.
NASA TD.
TD's go.
CMD.
CMD go.
Safety.
Safety is go.
Prop lead.
Prop lead is go.
Stage 1.
Stage 1 is go.
GCE.
GCE is go.
ACE.
ACE is go.
LD.
LD is go.
Go to begin propellant loading operations at T-minus 1 hour, 20 minutes. NASA PM LC on countdown 1.
NASA PM go.
And safety LC on countdown 1.
Safety's go.
Yeah, NASA PM and safety, I'd like to get standby. All right, stand down on countdown 1.
Don't change it yet.
I can announce countdown has resumed. Site control, arm and start RP1 tank desiccant hose retract. Verify when retract complete.
And in work.
And LCTLM on.
And RP1 desiccant hose retract started.
Stand by,
and
TLM.
Visually verified.
And site control, arm and start LO2 tank desiccant hose retract. Verify when retract complete. Go ahead, TLM.
And LO2 tank desiccant hose retract started.
Archiving has been stopped and restarted.
And LO2 desiccant retract visually verified.
And site control, command tell to pre-pull back position.
And in work. And command sent.
And team start of core low flow RP loading and low flow LO2 chill down to occur at T-minus 1 hour, 16 minutes. Phase 2 dynamic limits will be active. And Mars tell, LC on countdown 1.
LC, Mars tell, go ahead.
Yeah, can I get status on step 334?
Stand by, still in work.
And LC site control on countdown 1.
Go ahead, site control.
Yeah, we're going to have to reperform step 49 and recharge the rapid retract system. Just wanted to give you a heads up. I'm going to do that after pre-pullback is complete.
Copy. And do you have steps to perform that?
There's a note ahead of it saying that we can reperform the steps.
Copy that. And site control, I'll just look for your confirmation that that recharging is complete once you've completed that.
Yeah, will do.
And LC, Mars tell configured to pre-pullback.
Copy Mars tell, check step 334.
LC prop lead, countdown 1, step 336. I can confirm the start of low flow RP loading and the start of LO2 vehicle showdown. And LC prop lead step 337, I believe we do need a RP1 flow rate adjustment.
Copy that, prop lead.
Unloading.
Copy that. You're go to proceed with step 338.
And LC site control on countdown 1.
Go ahead, site control.
And that charging is complete. Step 49.
Copy that. Thanks for the update.
And LC prop lead on countdown 1.
Go ahead, prop lead.
Step 338, the RP1 low flow and L2 chill down rate adjustments were complete.
Copy that. Check step 338.
And LC prop lead, I can confirm the start of core high flow RP loading, step 339.
Copy that, prop lead.
Houston GC, Dallas ground, 60 BG21. Houston GC, Dallas ground, 60 BG21.
And LC prop lead on countdown 1. I have step 340 for you, start of core high flow L2 showdown.
LC copies. Okay, at this time, I'd like to poll for our readiness for the accumulator refill, step 341, GCE.
GCEs go.
EHS.
EHSs go.
Ops 1.
Ops 1, go.
Prop 2.
Prop 2 is go.
Prop lead.
Prop 3 will be taking this one.
Copy that. And Prop 3, you're go to proceed with HSS accumulator refill procedure and report when complete per Appendix Michael. You can do that on anomaly 1.
Copy. In work.
And launch team, current status, all systems are green. Be advised, we may run into a similar GTLM issue that we saw when we switched to open loop telemetry earlier in the count. If we do encounter that, we'll switch back to hardline data. That'll occur around T-minus 40 minutes. You may need to close your GTLM window and restart that from the desktop.
And LC, this is Prop 3. Accumulator refill is complete, step 342.
Copy that, Prop 3.
LC prop lead on countdown 1. I have start of core low flow L2 loading.
Copy that, lead. Check step 343.
LC prop lead, countdown 1, step 344, start of core high flow LO2 loading has started.
Copy that, prop lead. And GNC1, LC on countdown 1.
Go ahead, LC.
Step 345, provide flight computer trajectory file for launch operation.
Yes, we would like to select trajectory file 3 for today's op.
Ops 1, upload flight computer trajectory file.
LC Ops 1, trajectory file 3 selected.
Trajectory file 3 verified in telemetry.
And ground to vehicle comm nominal.
Copy. Check steps 345 through 348. Ops 1, verify orb nav settings.
Copy and work. LC Ops 1, orb nav settings verified.
Copy, Ops 1. Ops 1, initialize nav position.
LC Ops 1, orb nav position sent.
LC GNC1, telemetry verified.
Check steps 350, 351. And step 352, report readiness for GC align. GNC1.
GNC1 is go.
Ops 1.
Ops 1, go.
Elect 1.
Elect 1 is go.
Ready for GC align. Step 353, Ops 1, mode orb nav to GC align.
Selecting GC align on my mark. 3, 2, 1, mark, and the time is 10:03:45. 45.
GNC1, LC on countdown 1.
Go ahead, LC.
Yeah, I'm ready for step 354. Do you have status on OrbNav telemetry?
Yeah, still waiting for alignment status to reach one of the two states that we expect.
Copy, standing by.
LC prop lead on countdown 1. We have cold helium biosubmerged.
Copy that, lead. Check step 355.
LC, GNC1, step 354, OrbNav telemetry verified.
Copy that, GNC1.
And LC prop lead on countdown 1. Step 356, we have cold helium bottle charging started.
Copy that, lead. And TLM, step 357, configure launch vehicle decom source to open loop telemetry.
LC, TLM, copy and work. LC, TLM on countdown 1.
Go TLM.
Launch vehicles decom, switch to open loop, and I've got the time when you're ready.
Ready?
I have 10, 11, 10. And open loop telemetry is being received and nominal.
And NASA PM, reactivate radar sites and reinitiate C-band transponder interrogation.
NASA PM in work. LC, NASA PM.
Go ahead, PM.
Sir, we have active radars 5, 18, and 3, and all are locked on the beacon.
Copy that, PM. Check steps 359 and 360. Ops 1, enable local launch enable button at failsafe panel and verify local indicator is illuminated.
LC Ops 1, launch enabled and illuminated.
GSO, enable local launch enable button at failsafe panel and verify local indicator is illuminated.
LC GSO, launch enabled and illuminated.
Step 363, verify RCC enable abort buttons are enabled and illuminated. NASA PM.
LC, NASA PM enabled and illuminated.
RSO.
RSO enabled.
FSO.
FSO enabled.
NASA TD.
TD enabled.
Check all steps through 363.
LC Ops 1, global launch enable verified.
LC elect 1, launch enable verified.
Check steps 364 and 365. Ops 1, stop sending ECU commands.
LC Ops 1, ECU commands halted.
And LC, site control on countdown 1.
Go ahead, site control.
Yeah, we're going to reperform step 49, rapid retract charging again. I can let you know when it's complete.
Copy that. And launch team, you may need to restart your GTLM client from your desktop. Or you may try pressing the A button to clear it.
LCTD, we are green for toxics and debris.
LC copies. At this time, I'd like to poll for final FTS power on and arm command test. Safety.
Safeties go.
FSO.
FSO go.
Ops 1.
Ops 1 go.
Elect 2. Elect 2 is go. FSO, bring up command transmitter with check channel on.
In work.
And LC site control, charging is complete.
Copy site control.
LC, Wallops CT site on, check channel radiated.
Copy that, FSO. Check step 368. Ops 1, apply external power to FTSA and FTSB.
LC Ops 1, FTSA, external power on. FTSB, external power on.
FTS external power nominal. FTS safe, configuration verified, check channel being received, AGC's nominal. Step 371, Ops 1, transfer FTSA and FTSB to internal power.
LC Ops 1, FTSA and B, internal power on. External power off for both
And Ops 1, can I get a FTS internal power on time?
Yeah, internal power on time is 10:19:17.
FTS internal power nominal. Copy elect 2. FSO, send FTS receiver arm command for 2 seconds, then remove. Continue check channel when function removed.
Arm on my mark. 3, 2, 1, mark. +1, +2. Arm removed. Check channel continued.
FTS arm indication received. FTS currently indicates safe. FSO, verify FTS arm indication.
FTS arm indication.
FTS safe and arm and FTLU safe. And launch team, step 378, report readiness for recalibration of engine pressure sensors. MES2.
MES2 is go.
EHS1.
EHS1 is go.
Ops 1, recalibrate engine pressure sensors.
LC Ops 1 and work. LC Ops 1, engine pressure sensors recalibrated and ready for flight.
Ops 1, reset charge amps.
And work. LC Ops 1, charge amps reset.
LC elect 1, charge amp signals reset and return to flight mode.
And Prop 2, place OCCS into SAC mode and pause the HSS auto sequence control.
LC Prop 2, that's in work. LC Prop 2 HSS ASC is paused. And opening 8021 on my mark. 3, 2, 1, mark. (8021) is opened.
And LC prop lead, EHS RP configured for final countdown.
HSS ASC is running, has been resumed, and OCCS is back in auto mode.
Copy. Check all steps through 386. Ops 1, enable ME1 and ME2 TVC and EHA buses.
LC Ops 1 in work. LC Ops 1, TVC and EHA buses enabled.
Site control, arm tel for rapid retract.
And in work. And tel armed for rapid retract.
And LC Mars Tel, stand by for arm completion.
And GNC 1, LC on countdown 1, step 390, provide status of upper level winds.
LC, GNC 1, upper level winds are go.
Stage 1, LC on countdown 1.
LC, this is stage 1 on countdown 1.
Yeah, step 391, provide status of cold helium bottle supply pressure.
Helium topping is not required.
Copy stage 1, check step 391. 392 is not required.
And LC Mars Tel, Tel arm for rapid retract.
LC copies.
LC, this is CMD on countdown 1.
Go ahead, CMD.
Yeah, LC, just be aware that we're working an issue over Dulles MCC, and right now it's a no-go for it.
LC copies. Do we have an ETRO?
They're hoping to get status by L-15.
Copy. Ops 1, activate arm enable.
Copy and work. LC Ops 1, arm enable rotated, arm enable illuminated.
Ops 1, arm stage 1 controller ODM.
And work. LC Ops 1, stage 1 controller ODMs armed.
Ops 2, set stage 1 controller EPV VREF.
In work. And stage 1 controller EPV VREF set.
Check step 395. System, coordinate final adjustment to payload ECS step sent point. Report when complete. In work. LC system. Go ahead, system. Step 396 complete. Copy. LC stepping off console. LC back on station. Admin LC on countdown 1.
Admin on countdown 1.
Yeah, admin, there's a request to hold, 5-minute hold at L-11 minutes. We will hold CDT at 10:39:16 and resume CDT at 10:44:15.
Copy that, in work.
And NASA TD, LC on countdown 1.
Go for TD.
Yeah, TD, we'd like to hold for 5 minutes at CDT 10:39:16.
Hold at 10:39:16.
And resume at 10:44:15.
Resume at 10:44:15.
That's a good copy.
LC prop lead on countdown 1, step 397. We have an actual F1 level of 11 out of 11.
LC copies. Check step 397. And prop 2 LC on countdown 1.
LC prop 2 on countdown 1.
Yeah, is step 398 required today?
At this moment, it is not required, but it is, pressure is slowly increasing.
GCE, do you have a preference?
Preference on what? Sorry.
Do we need to close 80? Oh, sorry. Do we need to close 10:21?
LC prop lead, we monitor that until we configure for no adjustment in the note above.
Okay, prop lead. Keep an eye on that. If you decide you need to close it, you can execute 398 and report whether or not you've done so once that's complete.
Copy that.
And
Mic check, 1, 2, 3.
Core 1 LC on countdown 1.
And good morning. I'm James Brierton in Charlotte, North Carolina, and you are watching live coverage countdown to launch. The rocket there on the left side of your screen in Wallops, Virginia. We are streaming on the Carolina Weather Group and on WCNC Plus, where we have meteorologist Brittany Van Voorhees with us. We also have NASA Ambassador Tony Rice, who is the lucky one on the call right now from Fredericksburg, sitting outside. He's got a break in the clouds. We'll be showing you satellite here coming up in just a moment, but as we are rocking and rolling and counting down to a launch that we anticipate to be at 5:50 a.m. Eastern Standard Time. If you're just waking up, good morning and welcome to Standard Time. Here is a brief overview of what we can expect with this resupply mission to the International Space Station.
The latest Antares rocket will launch from Wallops Island, Virginia this weekend. This means folks right here in the Carolinas and all across the mid-Atlantic states may catch a glimpse. This rocket is a resupply mission for NASA. It will hold supplies, equipment, and materials for science experiments. It'll also house
catch some good information that way. I haven't quite figured that out yet, so we have to send up fresh laundry for them.
Tony Rice is an ambassador for NASA. He says the most exciting thing with this launch is collecting new scientific data. Experiments include bioprinting tissues, ovarian cell research to improve fertility treatments, and examining mud flow to help prevent landslides post-wildfire.
The benefit of, I hope I don't wake up, doing these tests in space is remove gravity from the equation. It really lets the scientists
if they get mad at you, your response is,
the launch will begin at 5:50 Sunday morning. Now, don't forget to set your alarm on a device that auto updates, like a cell phone. Daylight saving time ends the same morning. It'll still be dark since the sun won't have officially risen yet, but as sunlight hits the upper atmosphere, it'll illuminate the exhaust from the rocket. Look toward the east-northeast and keep an eye out for a little yellow dot in the sky. If you have trouble navigating where to look, just look toward the sunrise. Candace Jordan, the planetary administrator at the Shield Museum, says another cool thing about the launch is who it's named after, the late Sally Ride. She was the first American woman in space.
One of the first female CATCOM, so the ones that talk to the astronauts that are in space. So I think it's a really neat thing. She was a big women in STEM and STEM engagement.
For WCNC Charlotte, I'm meteorologist Brittany Van Voorhees.
This launch attempt, so we're going to have to scrub the launch attempt for today.
That's a scrub.
Okay, wow. Coming back out of that video there, let's listen to this.
Copy that.
They have just announced a scrub of launch due to a fire alarm at the control facility in Virginia.
You are go to abort the OCCS sequencer.
Copy invert.
And that will bring us back around to a launch attempt. Tony, did they say tomorrow morning?
They said required 24-hour recycle time. So, yep, 5:27 tomorrow morning.
I mean, I guess anything is possible in these situations, but Tony, you've been to lots of launches. Have you ever had a fire alarm in the control room?
We have scrubbed for the day due to a fire at the Dulles site for Northrop Grumman.
Fire alarm.
We are scrubbing for the day, and we'll look again tomorrow. Lunchtime tomorrow, Monday, November 7th, will be at 5:27 a.m. So we hope you can join us then. Thank you, and have a good day.
So we can cut that feed. There's nothing more that will be learned there. Yes,
we might as well talk for a minute, though. We all woke up.
Yeah, exactly. And each one of these is a little bit of an education, and here's more education. Yes, I have been to a lot of launches, and more of them are launch attempts than actual launches. I have. Your question was a good one. No, I have never seen a fire alarm, especially at a remote facility, cause a scrub like this. But it does point something out interesting here, and that's that there are facilities there on Wallops Island that are, obviously a big part of this launch. But a good part of the team is a couple hours away over in Dulles, Virginia, just outside the Dulles airport. You see the same thing with the SpaceX launch team. They've got, even when they're launching from Florida, they've got folks that are off in near Los Angeles, and we've all seen launch control in Florida with additional personnel in Houston. So there's facilities all over everywhere. Never seen a fire alarm cause a launch scrub before.
Well, yeah, because we have Artemis coming up hopefully next week, and they take off, like you said, from Florida and then hand over to Houston. 5:27, I believe, is what they said for this launch attempt tomorrow. Folks are tuning in, waking up early this morning, probably having the same feelings we are. But I think so many people have woken up, Tony, because they were hoping to see this in the sky along the East Coast. Is that still going to be possible tomorrow?
That should still be possible. I look to you two for the a forecast. We're picked very carefully of where we might be able to see that, whether we might be able to see that. What's the weather looking like tomorrow morning?
It looks a lot better than this morning, that's for sure.
Okay.
Yeah, we'll still see some clouds around. I don't think it'll be as much of a concern because it looks like the main line of kind of rain that's been causing some issues, at least here in the Carolinas, with all the cloud cover coming with it. It does look like a lot of that will be wrapped up by tomorrow morning. So partly cloudy, I would say, for the most part, but I don't think nearly as cloudy as right now. I mean, I was even telling you earlier, Tony, that I was looking at the cloud cover even where you are in Fredericksburg. And I mean, you were seeing some breaks at times, but I mean, it was for the most part pretty dense cloud cover. So
pretty socked down here.
I'm like, James, you're jumping to Monday night.
I'm sorry, man. I'm sorry, everybody. So yeah, but I mean, Brittany, I think you're right. I think so many folks here in our home territory, the Carolinas, or across much of the East Coast this morning are dealing with clouds more likely than not. But as we look ahead to tomorrow morning, I think more people are going to have a better show.
Yeah, I think much better in terms of the weather. I actually, James, remember we kind of joked about that the other day where I said, if I was in charge, I would just put it on Monday because the weather's going to be so much better. And you're like, well, too bad that you're not in charge. But hey, I guess a fire alarm beat me to it. But I think that's like, I think that's going to be much better for people who are actually really interested in kind of watching like the full stream and getting to watch it for long periods of time. I think if it had been this morning, it would have been like maybe a quick view. I think tomorrow they'll have a lot more long range opportunities to get a glimpse.
For this particular rocket, a clear view, a clear sky is going to be really, really important. It's a bit smaller than if you've seen a SpaceX launch before and been able to see it from Charlotte or wherever in the Carolinas. A lot more difficult with the Antares. This one is going to be taking more of a, we'll have to look at the trajectory, see if it changes any for tomorrow. I suspect the answer is probably no, since it's just a 24-hour turnaround. But it takes more of a southerly trajectory. It's a bit dimmer in the sky, especially during that first part of the launch, where all you're really looking at as a single smaller engine. So that dot isn't as prominent, that kind of yellowy orange dot moving in the sky. But what's really exciting about a launch like this is the possibility that we might be able to see the exhaust plume being lit by the rising sun. And that takes a really clear sky to be able to see something like that. So hopefully we'll have some better weather tomorrow.
Yeah, I think, Tony, you said this when we were chatting the other day about how oftentimes people say it kind of looks like a jellyfish. I was in Fort Myers before this and saw a lot of SpaceX launches, from there where you kind of see as, it gets in the upper atmosphere, it's illuminated. So to have like a clearer view, I think of seeing that is like going to be really important to people who are in the Carolinas who really, really want to take like this unique opportunity to get that view possibly. So.
Yeah, because we are here in Charlotte, and I can pop cameras up real fast. Brittany and I were talking about it right before we came on. It's still muggy, it's still kind of rainy, it's kind of dark outside, and that would have been probably a real damper for anybody further inland or across much of the Carolinas. So hopefully tomorrow is a better viewing opportunity. This unfortunate part is everyone's gonna have to wake up again tomorrow. Tony, I think you were gonna say something there.
Yeah, I'm gonna call it a morning and turn back in for another hour or two, because it is starting to rain here in Fredericksburg, Virginia, and I am smart enough not to sit outside the road.
Well, Tony Rice, NASA Ambassador, we appreciate your time as always. We know we use a lot of your time. Go get some more sleep. I've unfortunately already hit the coffee, Brittany, so now I think I'm in it for the long haul.
Well, you can watch Wake Up Charlotte starting at 6 a.m.
That's right. So if you're streaming us on WCNC Plus, that'll be coming your way in the next couple of minutes. Brittany, I know you got to.
We're gonna try again tomorrow.
I think we will have some sort of stream tomorrow morning. Yeah, I'll have to figure out the logistics of that, but hopefully folks will join us because I know they want to be able to step outside and see it in the sky. So if you're up for tomorrow morning, Tony, we'll figure out a way to make it happen.
I'll be back in the Carolinas, so I'll be right in the middle, a little bit closer than y'all, closer in Raleigh, but give it another try.
Thank you, Tony.
All right, Tony, thank you so much.
And it's 5:47 a.m. Eastern Standard Time on the Sunday morning. If you're just joining us, they have scrubbed this morning's launch attempt due to a fire alarm in the control center. Brittany Van Voorhees will have to peel off to go do WCNC television in a moment. Brittany, before you go, could you just let people know what is aboard this mission and why is it important?
Well, there's a lot of important things. I think one that's a little bit interesting that actually when I tell people they look at me funny, is that astronauts cannot wash their clothes in space. So fresh laundry, we essentially send them new laundry and they send it back. So pretty much the longest free dry cleaning service, I guess you could say, probably in the history of the world. But other cool things is experiments. I think that's like one of the big things that people probably don't think about that the astronauts are doing up on the International Space Station is they're doing experiments to improve our life, here on Earth. The big ones right now they are doing ovarian cell research to try to improve fertility treatments. I think that's really important for many, people across the country and the world, dealing with infertility. They're doing studies on how plants adapt in space. And they're doing 3D printing of different like biomedical engineering kind of stuff. So like, replacements of different joints, things like that. And I think that's all really cool because, of course, it all, again, improves our lives. What's interesting, and Tony actually is the one who I did the interview with, but he points out that one of the big reasons why they do this on the ISS is that gravity is taken out of the equation. So the astronauts and the scientists are able to really focus on the physics of the experiment. So it kind of takes out that additional strain, that we deal with, and they're able to kind of get down to, for lack of a better term, like the nitty gritty of the science. So that's really interesting too. So we get new data, of course, sent back to us, but then we're able to kind of replenish their supplies and things like that. So it's a lot of cargo.
Yeah, absolutely. No one aboard this particular rocket, other than the fact that it is named for Sally Ride, as they have, amongst other things aboard, science experiments from kids and other scientific missions, as Brittany mentioned, and also just things to keep life going there on the International Space Station. As we look ahead to a launch attempt for tomorrow, we showed this a few moments ago, but so much of the East Coast is socked in by clouds this morning, and we anticipate more people will have clear skies as we look ahead to tomorrow's launch at 5:27 a.m. Eastern Standard Time from Wallops, Virginia. Not clear up and down the entire East Coast, but more clear than we have this morning. As you look here on our model run this morning for precipitation, you can still see that we have rain throughout the East Coast and even just kind of humid moisture out there that is obscuring views. And as we look ahead to tomorrow morning, a lot of that will clear out. Maybe you'll have some interference if you're trying to watch from, say, upstate New York or Pennsylvania, kind of the outer reaches of this viewing area. But we will have more folks who are able to see this moments after it takes off tomorrow morning. We can show that map again here in a moment of where the launch will be visible from, because I know that's the reason so many people are waking up this morning, is because they were hoping to see moments after takeoff the vapor and the trail through the night sky or the early morning sky. But due to a fire alarm in the Virginia Control Center, they've gone ahead and scrubbed for tomorrow. Brittany, feel free to peel off anytime you have to, because I know you're on TV in T-minus 10 minutes.
Yeah, I will have to peel off now. But James, I just want to say thanks, of course, for inviting me. Hopefully we'll be able to talk more about this tomorrow morning. But thanks for getting up early, and hopefully you enjoyed your coffee. I just want everyone to know, of course, James really quickly mentioned Sally Ride is the one who this mission was named after. Apparently they do this with all the Antares rocket launches. Big reason for her, of course, was first American woman in space. And she was always a big advocate for women in STEM and STEM, research and trying to get kids engaged and things like that. So she's really important, I think, a big figure, right, for the future of, science, technology, engineering, mathematics, for young people and especially females, as we're always told as little girls, right? Don't be smart. So
well, absolutely, and I appreciate that context, Brittany. Appreciate your time this morning as you'll now transition over to the TV side of things. If you're streaming us on WCNC Plus, thanks, Brittany.
Hi, James.
The morning news is coming your way momentarily. If you're with us on YouTube, we'll stay with you until the top of the hour. And kind of to transition off of what Brittany was just talking about with the naming of the cargo capsule here after Sally Ride, it also reminds us of Artemis, of course, named for Apollo's sister. And Apollo bringing men to the moon some 50 years ago, and now Artemis returning us to the moon, and eventually with the first person of color and the first woman on the moon, hopefully by the year 2024, 2025. I bring this up, of course, because they just rolled Artemis out to the launch pad at Cape Canaveral. I guess it was now early Thursday morning, and they are set to make their next launch attempt for Artemis, the test mission there, the unmanned, uncrewed test mission on our drive back to the moon. And that will happen at 12:07 a.m. Monday, November, let's see, what day is that? That's the 14th. So conversationally, if you're making plans, it's really late Sunday night. You just have to kind of stay up Sunday night until the clock rolls into Monday morning. They'll have 3 launch attempts that week. That's the first one. But we are once again watching the tropics. It feels like Artemis is a magnet to the tropics. Launch attempts previously were delayed for Artemis because of Hurricane Ian. In addition to delaying Artemis attempts due to a fuel leak, it was Ian who sent the vehicle back to the vehicle assembly building, you're taking a look here at the weather outlook from the National Hurricane Center in Miami, and you can see two possible tropical systems that will be developing over the next 48 hours. But of course, the big one we're watching here is just off the coast of Florida and the East Coast. That could be causing some tropical downpours and wind, even if this doesn't make tropical storm status. Like if it never gets a name, we're going to be watching for some of this weather to come rolling on through as we get to the later half of the week that is starting anew today. So let's show you here on the GFS computer model what that might look like. And again, this is several days out, and we may never actually reach full-blown tropical status, especially here in the November timeframe. But as you look ahead to late Wednesday, early Thursday, you can start to see a low pressure system with moisture associated with it. You can see kind of an eye or an area of circulation off the coast of, say, West Palm Beach here. And even if this, again, is not a tropical depression or tropical storm or anything that has an official characteristic, you can see we're going to have lots of rain that could potentially move right over Cape Canaveral. So if you're a space fan, as you must be, if you're up with us early this morning, we're going to be keeping an eye on the tropics and for what impact that might have with Artemis out on the launch pad. But then also, of course, if you're watching us from the Carolinas or across the Southeast, even the Mid-Atlantic, you could be seeing some moisture from all of this. So we're going to roll this through one more time. This is not set in stone. This is just one computer model of what could happen, but the National Hurricane Center is watching an area of thunderstorms off the coast of Florida that over the course of the next few days could bring in name or not in name heavy downpours and wind to the Space Coast, and along with other portions of the Southeast that would eventually clear out by the end of next weekend. So while today's launch didn't get off due to a fire alarm in the control center in Florida, or excuse me, in Virginia, it is weather that again could be the main problem as we look ahead, Space Geeks, to Artemis next week. We also have a lunar eclipse that will be coming your way early Tuesday morning. If you're watching from the East Coast, as I imagine many of you are with the hopes of seeing today's rocket, then that eclipse will begin to pique your interest probably about 4 a.m. on Tuesday morning. So if you're an early riser, this is the place for you. Unfortunately, because of the timing and our position here on the East Coast, we won't really see the tail end of that eclipse because the moon will set, the sun will rise before the show is over. But you'll be able to see max totality if you want to get up early on Tuesday morning to see that lunar eclipse. You're just going to need a really low view of the sky, someplace that doesn't have a lot of trees. Could be the place you were venturing out to this morning as we were hoping to get this resupply mission to the International Space Station off the ground in Wallops, Virginia, again being scrubbed due to a fire alarm at the Launch Control Center there in Virginia. As Tony Rice, NASA ambassador, was telling us, he's been to lots of launches, seen them scrubbed for all sorts of reasons. Fire alarms, not typically high on the list. Weather is one that is typically high on the list. We were thinking the weather was going to be about 80% favorable at the intended launch time of 5:50 a.m. this morning there at the coastal launch facility that NASA owns in Virginia. The good news, if there is any, is that with the launch now scheduled for 5:27 a.m. tomorrow morning, East Coast time, more of you will have clearer skies. So many of us across the Carolinas this morning dealing with rain and fog that could have more likely than not blocked your view of the rocket. So tomorrow we will look to try to get this rocket off the ground once more, and it could be in the long haul a better viewing experience for so many of us. Before we leave you this morning, let's show you one more time so you can plan ahead for tomorrow what that launch pattern is going to look like. So assuming you have a clear view of the sky within seconds to minutes after launch, you might be able to see the trail, the vapor trail, and a streak of light in the sky. You're going to want to position yourselves towards the Virginia coast. So if you're in the Carolinas, that would be to the northeast. If you're in the northeast, you kind of want to look south. The rocket is going to take off towards the ocean and towards Bermuda, where they have a tracking station for this. The mission will eventually take that uncrewed rocket and the cargo capsule named after Sally Ride up to the space station to resupply the men and women working hard up there at the International Space Station. It's 5:58. I'm James Brierton in Charlotte. If you're watching us on WCNC Plus, the morning news with Brittany Van Voorhees and the WCNC Charlotte crew will follow momentarily. If you're watching us on YouTube, we will be wrapping up our coverage here on the Carolina Weather Group and on Weather IQ in just moments. And we will be back tomorrow morning with another launch attempt from Wallops, Virginia. And we'll also be back next week with coverage of what we hope to be a launch of Artemis 1. So for now, from Charlotte, I'm James Brierton. Thanks for getting up with us. Enjoy the rest of your Sunday, and don't forget to set back those clocks.